Hey everybody, so what we're going to be talking about today, it's of necessity, it's sort of a difficult ball to get rolling, but I hope once I hit my stride we'll have some fun. So we're going to be talking about mathematics, computers, Kabbalah, and the future of the internet. Not in that order though. We're going to try and cover as much mathematics as possible and computers, and jump to the future of the internet, and then we're going to come back to our local gang here and we're going to talk about the Kabbalah, and that part will be fun. That's happening that way because we got a couple of audiences here. Actually, let me put that entirely differently. There are two distinct things going on that have a relationship to each other, which we'll be exploring. One of them is that right now it is 7:30-ish p.m. in Chicago, Illinois, in the middle of November, and there are roughly a score people present who are listening to some words. There's also a camera, and so anybody who is seeing pictures or hearing words that is not matching the Chicago, Illinois 7 p.m. thing that we were just talking about is seeing and hearing an extraordinarily rapid stream of numbers, which is going to come up repeatedly, because that's the human condition, period, full stop. Analog and digital is a historical oddity. To draw an analogy is all that we do with digits with computers other than perform calculations, which I'm sure you all have done some stuff with computers recently. Probably you've even used a calculator app on your computer in the last month or so, but I bet that the last few things you did with the computer didn't involve doing arithmetic, or didn't feel like you were doing math. Even for people who are steeped in math, maybe 1/1000th of the mathematical things that we do are explicitly identified and tagged in the brain as such. Anything that happens in our physical substrate is subject to a certain amount of math. So we'll get to that next, I think. Raise your hand, and I am raising my hand, if you have failed a math class.
Yeah. Does a D count?
It's good enough. A D counts, trust me.
Yeah. They will count the D. I found that out. Yes, they will count the D. Yeah.
So I've got a minor in math. Eventually, I also failed algebra twice. One of the things that we need to erase is the impedance left behind by that experience. If we had all been taught to speak English and learn our vocabulary exclusively through crossword puzzles, there would be a small elite of people who naturally enjoyed crossword puzzles, who enjoyed the English language. Everybody else would have to speak something else. I mean, I don't know how a language could even survive being that uncool. So that's a difficulty that we have with mathematics that we're trying to address. So what I do most of my work on is the aesthetics and the representation of mathematics. So where we should I have my notes. There's a key bridge here. From the sensory to... Oh, okay, right. So mathematics is not an academic discipline. It's not actually even vaguely the sort of thing that should be associated with school. And if ancient Greeks were brought up into our modern world and showed things like non-Euclidean geometry, they would be perfectly capable of understanding it first. It would take a day maximum to get it across. The thing that they would have difficulty understanding is that we choose to consider the parallel postulate to be something which produces a certain kind of mathematics. And then there are other also incorrect postulates that we have thoroughly explored, and one that we suspect is correct. And that would take a lot longer to explain. So that's where I'm actually going to start, is with the Euclidean postulates, because we're going to be talking math here, and that's the place of great importance. So Euclidean geometry is still what we use for pretty much everything unless we're forced to use something else. And it runs basically like this. You have, and do it the quick way, you got a point, you go to a segment, you extend that segment, infinitely in both directions. Given that, and a compass, we make a circle. And there's something about the validity of right angles, and then you have the parallel postulate, which is wrong. And was controversial in the time of the Greeks. The Greeks were like, that one is missing a certain je ne sais quoi. At the time, the Greeks were still very strongly concerned with the utility and power of mathematics. They were burdened with certain lacks of understanding, as we all are. I spent a little bit of time trying to put that into historical context. What it mostly relates to is the incomplete understanding of the zero, which was being handled differently elsewhere. So a lot of our underlying conceptual confusion, and I'm going to get back to this in part 2, comes from the fact that we are descended from a one-based system of counting. So that's challenging also. So for instance, hopping back here a little bit, when you have the point, that's the first axiom, that's axiom 1. We wouldn't probably want to start with an axiom 0, but there's a lot of tradition behind that. So we're not here for tradition, so let's start with axiom 0, which is being in space, but not extended in space, or oriented in space in any sense. That's what we call point. It's the first step. It's where you've gone from perfect generality to some kind of specificity. And much like Euclid, we will extend. Since we're talking about computers, we're just going to be extending up next. For now, we're doing extension in the usual reflective way. So this is our first dimension. Now, normally you guys would think we got an extension, an extension, an extension, and then time, right?
That's
4
the three.
dimensions.
Yeah.
Yeah, that is not correct. It's not correct. What happens is first we have an extension, and that's our, first we have our isness, and then we have our upness, we have our extension, and 6 steps rotation around the other side. So then this goes back to the Euclid. So at this point, Euclid chooses to make a segment, make an infinite segment, and then pull out his compass and spin something, because he has a compass, and he's going to be doing everything with a compass and a straight edge. Because Euclid, like me, is stuck on the face of this planet, and it's not up there where things make more sense. And since we want things to make more sense, we're going to do things as much as we can from up there. So that after you've done this, you have your segment, you have your extension, you have your rotation. So you can have an axis created by that extension, and you can rotate it at the same time. One point out, you do have a choice, but it's not a real choice, because you can call this plus or minus. I guarantee you I can flip this upside down. And also, if I just call this plus and this minus, then if I just reflected it, which is perfectly possible in space, then that would be fine. But when it comes to this next one, you have to make an actual choice for yourself to extend. And then there is another rotation. So what is the point of this? So we have the same space that we're used to, but now we have 0 through 6, extension, rotation, extension, rotation, extension, rotation. So what just happened? Well, we've, instead of lettering our dimensions, which we would often do by saying X and Y and Z, and then A and B and C for the rotations, we're numbering them. We're going to number our orientations, and 0 is the origin, which is always the case. The odds are extensions. The evens are rotations. Okay? First extension, first rotation. Second extension, second rotation. Second rotation is a multiple first rotation, 2, 4. Third extension, also prime, also odd. Third rotation, multiple of first rotation, second extension. That's a fact. I don't know whether that's a result or not, because what we're doing here is not mathematics, it is meta-mathematics, which is the next step. So, what is it to say that we have a meta mathematics? It's been done before. The historical program of meta mathematics begins with Bertrand Russell, more or less. Forgive me, pedants everywhere, including myself. And more or less comes to a stop with Gödel. Their proposition was to do mathematics using the tools of mathematics, to explain the foundations and the substance of mathematics using its own tools. And Gödel proved that was impossible and starved himself to death. And that's where 20th century mathematics stopped. Which is just where computation started, interestingly. So, what do we conclude from that? Axioms. Oh, I skipped a bunch of good stuff. I'll get back to it. Yes. Right. The take home from the first wave of meta-mathematics is that meta-mathematics is not mathematical, which I'm sure will be a relief to most of you, because it's something which is more fundamental and important than mathematics itself, might then possibly be easier and more pleasant than everything I'm putting you through right now. I promise. So the second wave of meta-mathematics are people like, I can't read my own writing, Hofstadter, of course, Douglas Hofstadter, Christopher Alexander, damn, I feel bad for that guy because he's not getting mentioned today.
Just like a doctor, can't read my own writing.
Can't read my own writing. Buckminster Fuller.
Oh, come on, really?
Right.
That's
So these are people who are looking at what we are trying to do with mathematics. They're looking at mathematics on a systems level, and they're groping and exploring for meta mathematics.